Alright, let's take a look at the 711, which I hope is much like your 7-12, and I believe it is. Again, just kind of different values and numbers. And in this case, we're just going to try to find the z value. I'm going to take it a step further and kind of talk about some stuff that's going to become important as we go along. But we need to know the formula that's on page 214, right in the middle. It's a standard normal value, or a z value, is equal to x minus mu being the mean, divided by the standard deviation. So in this case, for number 11, it says the Camp family has twins, Rob and Rachel. Both Rob and Rachel graduated from college 2 years ago, and each is now earning $50,000 per year. Rachel works in the retail industry, where the mean salary for executives with less than 5 years experience is $35,000, with a standard deviation of $8,000. So it's giving us all the information we need. Rob is an engineer. The mean salary for engineers with less than 5 years experience is $60,000, with a standard deviation of $5,000. Compute the z values for both Rob and Rachel and comment on your findings. So both Rob and Rachel make $50,000. I put the retail first, so it's going to be a little bit confusing. Retail mean is $35,000, and the retail standard deviation is $8,000, whereas the engineering mean is $60,000, and the engineering standard deviation is $5,000. And remember, my z, and that's what I'm looking for, is a z value, is equal to my x, and x is the number that I have, right? The number that's given to me minus the mean. So it's the number that differs from the mean, I guess you would say, divided by the standard deviation. So it's a relatively simple formula, right? So my z value for Rachel is equal to, let's see, my x for Rachel is 50,000. Minus, and Rachel's the one that's in retail, so it's minus the mean, okay? And I'm going to need parentheses around that, sorry. Okay, and that's divided by then the standard deviation for retail, which is the 8,000. So that gives me a value of 1.875. And Rob's is the same way. Again, we just have to plug in the formula. It's equal to, parentheses, Rob's x is the same, minus the engineering mean, which is 60,000, divided by the engineering standard deviation, which is 5,000. So Rob comes out with a minus 2. Well, what's that tell us? Okay, because it does ask for me to comment about that. Well, let's see here. Well, I guess I would comment, it's pretty obvious that Rachel makes above the mean. She's actually about almost two standard deviations above the mean, okay, which would put her, if you went back to that deal, that would put her in the top 5%, right? And Rob's about two standard deviations. He is 2 standard deviations below the mean, which would put him in the bottom 5% if we go back to that empirical rule. And we can even be more precise than that, and that's where this comes in. And what I want you to do is, if you open up your book to page 732, kind of areas under the normal curve, and I don't think I have this. I should try to see if I do. But areas under the normal curve, I'm going to pause because maybe I can find it. All right, I found something actually even kind of more cool when I went and looked it up on the internet. I just kind of wanted to give you guys an idea of what it looked like. I was hoping to get an Excel table, but this one's even kind of cooler. So this might come in handy. You might even want to save this site if you need it. I'll try to save it maybe and post it. But so Rachel's z-score is 1.875. Well, what's that mean? Well, I like this interactive tool here, because what we want to know then, right, is how she's 1.875 above the mean in terms of standard deviations. Well, what's that put her as a percent, right? We often talk about grading on the curve or doing some things like that, but what's that put her as a percent? If we were talking about IQs or anything, right? We oftentimes want to know that. Okay, well, how do I find that? Well, this is really cool, this tool here, because if you'll see at the bottom is the z-score, and that's what I'm looking for, but I want 1 point, so I'm just going to keep going, 1.875. 81. There we go. Oops, it's hard to hold it, but okay, 46.78, but that's above the norm or above the mean. So you'd have to add that to the mean, okay, which is 0.5 in this case, or 50%. So 96.78%. She's above or at that level, 96.78%. What's cool about this tool is I could click on, I think, the up to, and it goes to minus, and it'll actually do the addition for me, is basically. So I find that 1.8, was it 1.875? What the heck was it? 1.85 or was it 1 point? I gotta go look. Oh, 1.875. Okay, so this number's a little bit off. Okay, and I changed my number there, and I shouldn't have. So I'll go back to that. It doesn't give me 875, so I got to go to 1.87. Okay, and then half, so I'd be 96.93, and then halfway between that to 88. Maybe if it'll do it. Oops. 96.99. So it'd be 96.96 is halfways in between those. Okay, 96.96 is halfways in between those, and that's kind of cool. Now I got to look at the boy Rob, right, and he's right at minus 0.2. Okay, so that's oops, right there. So he's in the bottom 2.28%, or 90-some% or higher than him. That's probably what this will say, yeah. And you see it keeps it shaded, right? 97.72% of them are higher than his pay, really, if you look at the standard deviation and whatnot. So this is really a cool tool. I like this. I'm going to save this, I think, so we can kind of take a look at it. But we can also come down, and this is what you'll find in the back of the book, and if you don't want to come and use that tool up there, then we would do this. Okay, so we'd have to come down to 1.8. We'd have to come here to 1.87, and it's a little bit tough, right? 6, 7, 8, so I'm in this column. So 0.4693, and remember then I'd have 0.4699. This is for her, for 1.875. I have to interpolate that. So halfway's in between those roughly is 0.4696. Okay. And his is minus 2. Okay, and remember I'd have to add half to that because I'm above. I'm a positive. So I have to add half to that, which gives me the 96.96, right? And in his case, I'm 0.4772. So let's take a look. What I have to do then is subtract. I have to say that's equal to 0.5 minus 0.4772, or the 2.28%, if I was to put that in a percent, right? Okay. And in this one, I had wrong because it should be 0.5 plus 0.4696, wasn't it? Oops, I got to put my equal sign in there. Sorry. Yeah, so I end up with 0.9696. Now, there is a way that you can do that by Excel, but it's kind of nice to get used to using the chart thing. Yeah, that gives you a great visual. You know, this particular chart gives you a great visual, and so I may well post this for you guys. Thanks.